All right, today we're taking a deep dive toward the heart of our galaxy, the Milky Way, to check out a star that is so extreme, so incredibly powerful, it's honestly hard to believe it's real. We're talking about the Pistol Star, one of the most massive and luminous hypergiants we have ever found. But here's the crazy part. For all its unbelievable power, you can't see it. I mean, not with your own eyes, not even with a regular telescope. So, what if one of the most brilliant stars in our entire galaxy was hiding right there in plain sight? You see, if it weren't for this cosmic curtain of dust, the Pistol Star would be what astronomers call a fourth magnitude star. Now, all that really means is that it would be bright enough to see with your naked eye on a clear night. You could just look up towards the constellation Sagittarius, and there it'd be. So what's hiding it? Well, the culprit is really its address. The Pistol Star is about 25,000 light-years away from us, and it's right in the middle of all the action near the galactic center. That whole part of the galaxy is just choked with these gigantic clouds of interstellar dust, and they act like a thick veil, soaking up almost all of its visible light before it can ever get to us. So, how in the world do you find a star that's practically invisible? Well, this is where some really clever astronomy comes into play. Let's dig into how this incredible discovery was actually made. So, back in the early 1990s, an astronomer named Don Figger and his team pointed the Hubble Space Telescope right at the galactic center. But they didn't look for it in the way you or I see light. Instead, they used infrared, which has this amazing ability to cut right through those thick dust clouds. And suddenly, there it was, this unbelievably bright star that no one had ever seen before. And what exactly did they find? The Pistol Star is what's known as a luminous blue variable, or an LBV for short. And you've got to understand, these things aren't just big stars, they are cosmic ticking time bombs. They are insanely rare, unbelievably massive, and super unstable. They're famous for these violent, unpredictable outbursts where they just shed huge chunks of their own mass into space. You know, with a star this dramatic, you'd expect it to have a pretty memorable name. But the story behind how it got that name might actually surprise you. Yeah, the star itself doesn't actually look like a pistol. What's happening is that its immense energy is lighting up this huge cloud of gas that the star itself blew off ages ago. And that nebula, the gas cloud, just so happens to be shaped like a pistol. So the star is the engine, but the nebula is what gave it its famous name. Okay, now let's get to the really mind-bending part of this whole thing. The numbers. This is where you start to really appreciate why the Pistol Star is considered one of the most extreme objects in our entire galaxy. Let's just start with this one. Staggering figure. The Pistol Star shines up to 3.3 million times brighter than our own sun. The amount of raw energy it's pumping out is just almost impossible to wrap your head around. And this table here really puts it all into perspective. I mean, compared to the Pistol Star, our sun is like a tiny little pocket flashlight. Its radius is over 400 times bigger, and its surface is more than twice as hot, burning away at a crazy 12,000 Kelvin. That's over 21,000 degrees Fahrenheit. And this quote just perfectly captures that difference in power. Let me just say that again, because it's wild. Everything our sun produces in an entire year, the Pistol Star blasts out in just 10 seconds. It is an absolutely unfathomable amount of energy. And to help you picture just how enormous this thing is, imagine for a second that we swapped it with our sun. If the Pistol Star was sitting at the center of our solar system, its surface would completely swallow Mercury and Venus, and it would reach all the way out past the orbit of Mars. Now, here's something I find fascinating. Even with all our amazing technology, we're still not 100% sure of its exact mass. When we analyze the light from the star, its spectrum, we get a mass around 27.5 times that of the sun. But when scientists use our best models for how stars evolved, they get a much bigger number, somewhere between 86 and 92 times the mass of the sun. And you know what? This isn't a failure. It's actually super exciting for astronomers because it shows how these giant stars are pushing our understanding of physics to the absolute edge. A star this extreme doesn't exactly live a long, quiet life. Its whole existence is basically a story of nonstop cosmic violence. We talk about the sun's solar wind, right? Well, the Pistol star's stellar wind is on a completely different planet. It's a raging storm of particles blasting off its surface that is over 10 billion times stronger than our sun's. This is how it's constantly shedding so much of its own mass into space.
So let's just look at its life story. It formed only about 4 million years ago, which in star years makes it a toddler. But it's already had a super dramatic past. Just a few thousand years ago, it had these huge outbursts, throwing off material equal to 10 suns. And its future? Well, it's going to live fast and die young. It's expected to explode in a brilliant supernova, or maybe an even crazier explosion called a hypernova, sometime in the next 1 to 3 million years.
So, what's the big takeaway here? What does a star like this really tell us about our home galaxy? And why does it even matter?
Well, here's the thing. The Pistol star isn't some lone wolf. It's actually a key member of what's called the quintuplet cluster. Think of it like a crowded, chaotic downtown neighborhood that's just packed with massive, young, energetic stars. Studying places like this is absolutely crucial because it gives us a front row seat to the violent, high-speed processes that build the biggest stars and really shape how whole galaxies evolve.
And that brings us to one last thought. The Pistol star was an incredible find, a true monster hiding behind that veil of cosmic dust. And it really makes you wonder, doesn't it? If a star this bright and this massive could stay hidden from us for so long, how many other cosmic secrets, how many other unbelievable giants are still out there just waiting for us to find them in the heart of the Milky Way?